Hey there, space weather enthusiasts. The excitement continues. We've got a KP7, a solar wind over 800 kilometers per second. Incoming solar plasma, cosmic ray report, and lots more to cover today at the Smash News Network, least busted name in news, and thanks for tuning into the channel. We're frankly surprised to notice that you've noticed that the channel exists. So this is the past 24 hours of El Sol in the house favorite 171 angstroms wavelength. It's just gorgeous stuff there. This wavelength is great at showing the lower corona. Lots of ionized iron there aligning to filaments. Now we've got a bunch of images to share here from Twitter. If you didn't join us on Twitter, you're missing out on things like this. There's some Aurora Australis. This is the banks of Lake Huron last night. Some Aurora Borealis there from Canada. And there is some pink and green aurora from the Scottish Highlands. Let's take some closer imagery of the sun here. We've got these active regions setting in the northwest. That raises their likelihood of solar flaring. We've also got some equatorial sunspots appearing. We'll talk about that in a moment. So huge prominences happening there. Huge prominence down here. We named this one Lex Friedman, as we've been naming filaments after living people. Also huge filaments over here. This is the Hillary Clinton. This is the Kamala Harris. If you want to name filaments, follow the hashtag #NameThatFilament on Twitter. Here's the southeastern limb. Let's cut to the full disk view of this wavelength. So a huge number of filaments. Some new sunspot groups showing up around the equator, some spontaneously forming right here in the Earth-facing portion of the solar disk, and one rising over here in the east. Let's take a look at those in the SDO continuum. That's the SDO intensity gram, actually. So 2 new sunspots likely to get named in here. We probably will see a drop in the sunspot number, as this group up here is quite large. However, these groups are looking promising, and of course there is a new sunspot that just rose on the east. Right over there, that one's only alpha class. And here are the magnetic fields to give a little bit more detail on the recently grown sunspots. We'll show you some more imagery of that a little bit later in the video. We'll show you the ultra high res to check and see if those are beta or alpha class sunspot groups. If you haven't checked out smashomash.com/SmashTeam, well, it's the official subscription services site of the Smash News Network, least busted name in news. We are using that to attempt to fund our operation thanks to our new members. A bunch of new gold Smash Team members showed up, so thanks for that. If you want to assist us writing the paper that explains the mechanism underlying the solar sunspot cycles, consider becoming a gold Smash Team member, as we have already divulged the hypothesis surrounding that. So thanks to our Gold Smash Team members. Don't forget to respond to Smash staff's emails. We do give out custom @smashomash.com email addresses to our Gold subscribers. The best value is a Gold annual paid-up subscription. It includes complimentary merch. Click posts to see the latest posts for your level. There's a Gold level, a Silver level, and a Bronze level. And let's move to volcanoes. And check it out, down in Guatemala, Fuego has been showing up great on some time-lapse imagery there. Some serious lava fountaining there happening at Fuego. Great imagery there from volcanodiscovery.com. And let's see what else is erupting here. We'll do a brief rundown and get back to space, as there's plenty to talk about in the realm of space weather. So Shivaluch is exploding. It's producing a 13,000-foot ash plume over Kamchatka, 8,000-foot ash plume over Sakurajima on the Isle of Kyushu, Japan. Subanose Jima exploding, flight level 080, 8,000-foot ash plume over the Ryukyu Islands. Dakono exploding, flight level 070 over the Isle of Halmahera. That's part of Indonesia, by the way. Fuego, there you go. 15,000, we'll say a 16,000-foot ash plume over Fuego, flight level 160 over Guatemala. Headed down to Ecuador, Sangay, Revenador, and Cotopaxi all exploding. 19,000, 17,000, and 22,000 foot ash plumes from those three Ecuadorian volcanoes, respectively, and intermittent emissions from Sabancaya in Peru, as Sabancaya is also erupting. Here's looking at seismicity for the past 90 days, and we've had a little uptick in earthquake activity. No major quakes over the past 24, several in the 5 magnitude range that we will cover. Keep in mind, folks, any earthquake can be a foreshock. So don't assume that a 5 magnitude quake is the final word there, like this 5.1 at the Flores region of Indonesia. That occurred at 1641 yesterday, Universal Time. It was a 5.1 magnitude at nearly 200 kilometers depth. So we'll just scroll up the list here so you can see where the quakes are happening. Kyrgyzstan, near the Kyrgyzstan-Xinjiang border. There was a 5.1. That was at 23:58, just a couple minutes before midnight Universal Time. And then an hour and a half later, approximately, a 5.6 struck Indonesia. And then 5 minutes later, Kermadec Islands. So a 5.6 at Indonesia, followed by a 5.1 at Kermadec Islands. And then about an hour and a half, an hour and 20 minutes after that, a 5.0 at Turkey. Perhaps an aftershock. Then Fiji had a 5.6. That was at 6:40 this morning. 6:40 Universal Time. 5.6 magnitude quake there at 548 kilometers estimated depth. That would have been like a 7 magnitude quake had it been at the surface. Also a 5.2 struck eastern Turkey at 9:04 this morning, a 5.5 at the Solomon Islands. That was at 9:50 this morning. So quite a few quakes there in the 5 magnitude range, but no large quakes. At least not larger than a 5 magnitude. And let's get back to space with our custom HelioViewer video here. This is the last 24 hours of ionized helium. 304 angstroms from the ever-popular SDO. What a glorious spacecraft that is. And don't worry, we've got more of the best imagery you'll find anywhere on the Internet of the Sun. Here's 131 plus 171 angstroms. Again, that is the past 24 hours. The next we'll move to a bunch of solar data here and cosmic ray reports. So the 10.7 centimeter radio flux has come up to 159 solar flux units. There is a 1-year chart to put that in context. It's the black line. The red line below it is the sunspot number. And it looks like there's a little uptick in the sunspot number there. It's going to, well, it might be around flat today, as we've got 2 new groups forming near the equator and some groups setting in the northwest. So here is the Space Weather Enthusiast dashboard. Check it out. Solar wind here still over 800 kilometers per second. Let us know what you thought about the accuracy of our forecasting. Here's NOAA's forecast. NOAA forecasting for continued geomagnetic storm and geomagnetic unrest conditions into March. So now we are expecting the next CME, also generated from the Tamitha-Skov filament. The next CME, we are expecting it to arrive late on the 28th to early on the day on March 1st. I think I might have misspoken yesterday and stated that it's going to come in on the 29th. Of course, the 29th is not a thing this year. It's not a leap year. So that's the NOAA forecast there from the Space Weather Enthusiast dashboard. And let's just take a look at their Enlil spiral. There's NOAA's Enlil spiral, their modeling of the CMEs. And it looks like they're forecasting that to arrive a little bit earlier. For some reason, they have the second CME as a very high-speed coronal mass ejection. I'm not so sure about that, but that's okay. Let's move on. Here is the NASA Enlil spiral. Please note the time and date stamps in the upper left. NASA seems to think that's quite a high-speed CME as well. So not so sure about that. I'm not changing my forecast. I'm expecting it to arrive late in the day on the 28th. Keep in mind there is also a coronal hole high-speed stream which could muddy the waters for the solar wind telemetric signals. So check it out. KP7 is where we currently are. G3 geomagnetic storm there. KP7 is the current situation. That is significant to the point where we did take some video of aurora over Lehigh Valley, Pennsylvania. That's where we're located, by the way. And we're going to take a look at some more magnetic data here, but first let's take a look at cosmic rays. So you may have thought cosmic rays would have precipitously dropped off when we had a proton event. We'll go over that a little bit later in the video, but check it out. They didn't really drop off at the proton event. There were actually two separate events, and check it out, no major drop-off in cosmic ray flux, at least not at DOMB Antarctica. So a big dip in the last 30 days, though, at DOMB. DOMC Antarctica also showing a large reduction in cosmic ray flux over the past 30 days, and a big reduction in the past few hours at DOMC. Also, Oulu, Finland, showing a big dip over the past 30 days and a big dip over the past few hours, as there is certainly lots of plasma around planet Earth. Let's head south to Mexico here, to the Mexico City Cosmic Ray Observatory. You can see a reduction in cosmic rays at Mexico City over the past 30 days and the past few hours as well. Perhaps no surprise there, as there is certainly a lot of high-speed and high-density solar plasma out there hanging out. Next, going a little farther north to Greece. There's Athens, Greece. Also a big dip over the past 30 days there, a reduction in cosmic ray flux. And let's go back up north to Apatity and Barentsburg. A reduction in the past 30 days and a reduction in the past few hours at both monitors. So there's the 30 days at Apatity and there's the 30 days at Barentsburg. A significant reduction in cosmic ray flux there at all of our monitors. So always interesting indeed, and thanks for leaving comments, Mr. Bordages. And let's get to our Geospace Magnetosphere movie next. Bring that back. These are the past 4 hours of magnetohydrodynamic pressure around planet Earth. We've got some huge variations in the solar wind there, so that's likely creating some big variations in the pressure environment. This model depicts magnetohydrodynamic pressure. The units for that is nanopascals. It is based on the space weather modeling framework. So here's our ground magnetic perturbations map, and quite a lot of significant ground magnetic perturbations here. This map will show you the most likely places to see the aurorae, pipeline, railway, and power grid induction. Telluric currents are going to be the most prominent, where you see those dark red areas. You see a big uptick right at the end there. Let's let that play through one more time here. Keep in mind this is the last 4 hours. Also, there are time and date stamps there right on the imagery. So major changes happening there to Earth's B field as a result of induced current. So it's been a very interesting coronal mass injection impact indeed. And let's take a look at the U.S. power grid there. So there is the geoelectric field. And, this is empirical data. This is not any sort of a model. This is actually the data measured, the actual induced electricity there in the grid. You can follow that yourself. It's the geoelectric field 1 minute model. It's part of the Space Weather Prediction Center. So one of the many data sets there that NOAA will provide. And it's a well-known thing that certain parts of the country are more susceptible to induced power from induced electricity from space weather. Once again, this does show time and date stamps. This is the past few hours here. So the grid could take some spikes today. Keep in mind, most first world nations, their grid is fairly well protected. Most transformers will shut off before they burn up. So let's go out to Lagrangian point 1, the location of the ACE and Discover spacecraft, to take a look at the real-time solar wind. And a quick note about the real-time solar wind: there are all kinds of components that we don't typically look at on the channel. So if you click on Series, You can make all kinds of changes here. For example, you can include the predictions if you like. So I just pressed OK there. Give that a minute to reload. And now you can see the predictions as well. That might be a benefit for you. We don't typically show that on the videos, but you can also show different components of the magnetic field. You can show only the discover, only the ace, and so on. So just so you are aware of that. So that's the past day of solar wind. And check out these big spikes in the solar wind data there. Getting up to pushing 900 kilometers per second there. The highest reading I'm seeing is 865 kilometers per second. Current conditions are still heavily elevated there at 824 kilometers per second. However, the BZ, the magnetic field component's vertical portion, has now moved into positive territory. So if that stays as a positive territory signal, that positive BZ, which is that red line right there, we should see a simmering down of the geomagnetic storm conditions. The fields aren't super strong at the moment. So check it out. We've got a BT of only 7 nanotesla and a BZ of positive 2. So that should calm things down a bit, maybe dropping down to KP5, something like that. But yeah, so lots of potential for additional stuff to happen here. We are also expecting a coronal hole high-speed stream. So kind of looking for a density spike here. And in fact, we might already be seeing that. So keep in mind, coronal mass ejections and coronal hole wind streams do have the ability to interact with each other depending on their field orientation, their timing, their speed, all kinds of features. So anyway, that's the current situation. Current solar wind conditions here, only 3.61 protons per cubic centimeter. Solar wind velocity, 824 kilometers per second. So that probably is the coronal hole high-speed stream component. I suspect that the CME is in the process of subsiding here. So we'll have to see if these numbers smooth out and look like a coronal hole. Check out the GOES magnetometers. Those are all over the place, as lots of coronal plasma showed up in the past, I'll say 18 hours. So it's been exciting times for space weather indeed. Those are our GOES magnetometers. And let's take a look at the heliospheric current sheet next. First, take a moment to visit the links below the video. If you haven't checked them out, we do have a Redbubble shop. It's one of the many ways we attempt to support the channel and make it sustainable. So thanks to everybody who's picked up merch. The links below the video will show you our Redbubble shop in order of best selling. So check that out. Today's featured product is the third of the Do the Math series. This one features composite imagery of Sagittarius A star. So Sagittarius A star is a galactic core. It's right about there. And yeah, do the math. 8 equals capital D. Of course, Big Tech did the math. That's why we're still not at 3,000 subscribers on YouTube. So if you're unwilling and or unable to open your cobweb-encrusted wallet and pick up some merch or becoming a member of the Smash team or something like that, maybe consider pressing the like button. Press the share button. Leave us a comment. Tell your friends and foes about us. And hopefully, you don't suck at math. Hopefully, you're not watching YouTube channels that suck at astrophysics, cosmology, space weather, etc. So we invite you to do the math and tell your friends and foes about it. All right, so here is our heliospheric current sheet. We are right in the south magnetic pole right now. So the south magnetic pole of the sun right now directed right at Earth. Earth kind of right in the middle of it. We've got fields mixing up here at the northern part of the sun there. You can see the North Pole has South and North Pole magnetism, and that North Pole magnetism has to leave the North heliographic pole in order for the field reversal process to really get started in earnest, which means we've got a long way to go to solar max. We ain't there yet. So here's our line of sight field plot, and yeah, super exciting stuff going on here. And welcome to the South Pole. Yeah, the South Solar Polar, the South Polar Magnetic Polar region. You are in it. Welcome to the South Pole. And let's take a look at coronal holes. So the ones in the Earth-facing portion of the solar disk are almost entirely South Pole oriented. A couple setting there around the western limb. There's the latest image. You can see the way that B field is all fanned out. That's typically what you'll see when you are in the south solar polar field. I would also note that coronal holes are radio jets. So there are high-speed protons coming out of these coronal holes, and they are a super important feature of the solar cycles as they give us insight into the solar polar field reversal process. Let's take a look at that in 211 angstroms. We've got another very well-defined coronal hole right over here. We can expect to see some significant effects from that as it's quite close to the equator. Transequatorial coronal holes are the most geo-effective type. Next, we'll move on to sunspots. And we're going to have, they've already named this one. So we've got one new named sunspot. This one over here will get a name also. That'll be probably 3238. And then this one up here will be 3239. So we'll have at least two new named sunspot groups today. I can't believe they haven't named this one over here yet. It was totally obvious at the end of yesterday's video. And the most likely place to see major solar flares would be from this sunspot group right here and this setting group in the northwest. So the northwestern limb is the place to watch for flares. And let's take a brief look at sunspots. There's another view. That's the SGO continuum for the past 24 hours. Good times indeed for space weather. And all of those folks who are measuring magnetohydrodynamic waves, they should be having a good time right now, as there are plenty of them. So we do see a subsiding of the proton events here. I expected this to last a little bit longer, but it's subsiding rather quickly there. But there are still some blackouts going on. If you want to follow those yourself, you can by looking at the deabsorption predictions. So those protons emit radiation, which attenuate portions of the ionosphere, which cause radio signals to, instead of refracting back down to Earth, go off into space. The ones around the equator, those are from the solar flares themselves, X-rays. The ones around the poles, those are from solar protons. So there you go. Attenuation of the ionosphere continues here as protons are encircling the poles, especially the South Pole. After all, it is summer down there. So that's what's going on. Exciting stuff in the realm of space weather. And welcome to the most comprehensive space weather and detailed solar imagery you'll find in the known universe. Next, looking at solar flares. And interestingly enough, the flaring has actually dropped off. I'm not sure if it's because of a lunar eclipse on the GOES 16. We did see one last night. I mean, those big dips there, those are definitely lunar eclipses when the moon gets in between the GOES 16 and the sun. So that's what those big dips are. I suspect the X-ray flux is still more around like a C-class level, but it looks like it is dropping down there. So we'll have to continue watching that. That's the past 3 days of solar flares, not to be confused with coronal mass ejections. And here are our favorite flare wavelengths, 131 angstroms for the past 24 hours. Not too shabby. And here is 94 angstroms. Pardon my mode of dress today. I am dressed like a vagabond. Yeah, like a vagabond. Or you could say like a derelict. Those are good words, vagabond and derelict. Not used as much in American English as they are in British English. So it was a long night last night, and my sleep was limited. So let's take a moment to look at what's going on overhead. So tonight might be a great night to head out and take a look at the sky after sunset, as you'll see two of the brightest objects there, Venus and Jupiter. Now, Jupiter is in some ways the fourth brightest object as Jupiter and Mars trade places. I think Mars is actually brighter right now than Jupiter. It was out last night, and yowzers was it bright. The red planet was quite red. Anyway, if you're checking out the sky after sunset, you should see the third brightest object, Venus, and at the moment, fifth brightest object, Jupiter, in the evening sky as they chase the sun across the ecliptic. So here is our solar system forecast. That is, by the way, from theplanetstoday.com. Keep in mind this imagery is not to scale. Objects in space are very, very far apart. And let's move this ahead 1 week. Here's where things will be in a week. We're about eight days from a full moon here. The March full moon will be sometime around the 7th. Let's take a look at some coronagraphs next, as we do see additional coronal mass ejections. Are these earthly directed? Well, we'll let you know here in a minute. That's 108 frames from yesterday. And there may be additional ejecta headed toward Earth. It's very diffuse, so it might not create the kind of signal that we've been seeing here. But there does appear to be a little bit of an extra ejecta headed toward your doorstep. That's 52 frames from today. Let's take a look at stereo A also. We've put up a video of stereo A and Soho Lasco C3 located at Lagrangian point 1. So from Lasco C3, Earth would be behind you. From stereo A, Earth would be off to your right. If you were hanging out on stereo A, and we paused it here because, well, we've got this great, looks like a sperm cell there, looks like a flagellate, and there's a great still image there. That's 1109 for stereo A and 1106 for Soho Lasco C3. Let's just bring those back here, and we're going to let those play through. So now keep in mind these are different time frames. So I believe there is one additional CME headed toward Earth. It's fairly diffuse. It doesn't look like it's of particularly high speed or anything like that. You could expect that to arrive right there. So let me bring that back right here. This little CME right there. That may be on the Earth line. Let's see if we can corroborate that with Soho Lasco C3. So that's 11:53 today. And nope, it looks like it's off to the west. So no additional CMEs likely headed toward Earth. Here are our 24-hour coronagraph plus SDO 304 angstroms wavelength. A lot of that ejecta is actually on the far side of the sun. Now you may see a little bit of filamentary movement here. We'll zoom in a little bit closer for that. So the fireworks certainly continue. Again, it's an exciting time for space weather. And indeed, it's becoming an exciting time for things like cosmology and astrophysics, too. Thanks to everybody who's been supporting the channel, the past pushing 6 years. It's been interesting, to say the least. It's like in science, you end up with answers to questions not asked, and more questions, typically, if you're doing things right. So here is our filament view, and there are still a huge number of filaments. We're not even going to worry about saying name that filament. If you want to name a filament, feel free. Keep in mind we had 9 named filaments here. I've lost track of which ones are which. Check us out on Twitter to see what we've named what. So there's the latest image. Huge number of filaments here. The likelihood of coronal mass ejections sort of in the earthly vicinity here, nearly 100%. Remember, folks, you don't need to see sunspots or solar flares to see coronal mass ejections. They happen all the time without any such thing. So once again, you as our viewer, you're invited to follow us over on Twitter. You'll see all kinds of stuff you won't see anyplace else. We're all over the internet at Smash-O-Mash. And you can find a link to the free Hemp Lucid Gummies giveaway. So there's a link right there pinned to the Twitter profile. Thanks to our Twitter followers. And screw you to Twitter management, who still has shadow bans in effect. This is what you'll see if you click the link pinned to the Twitter profile. You'll see a description of what you get. If you haven't tried out mushroom gummies, check them out. All kinds of different solutions there to various things, whether it's stress, focus, sleep, and more. Here's the past 24 hours from SDO. This time we're looking at 1,700 angstroms plus 94. Again, the last 24 hours depicted here, and thanks for leaving a comment from Chile. Looks like a new viewer there. Aguz Herrero, thanks for tuning in. Congratulations on realizing the Smash News Network, least busted name in news, exists. Here's the past couple of hours from the GOES 16 SUVI. With its great wide field of view, it's spectacular at showing coronal mass ejections. And check it out, the Lex Friedman filament here might be becoming unstable. It looks like it's anchored by less and less plasma there, so the likelihood of that filament ejecting perhaps going up. And let's move to our bonus feature segment. So next we're looking at charging hazards here. So satellite charging hazards, we do see minor charging hazards over the central Pacific Ocean. Those are of the surface charging variety caused by low energy electrons on the outside of spacecraft. Here is our GOES electron flux that's measured at the F layer of the ionosphere by the GOES 16 and GOES 18. Low levels of electron flux as we forecasted yesterday, and that is practically exactly what we forecasted. NOAA now changing its forecast to agree with me for the next data point there. No surprises there, although this third one will probably also be down here. So that's the NOAA forecast versus my forecast. The pink dots are my forecast. And we'll stick with about 3 days there, as that is sufficient for the purposes of our videos. There's the one-year chart to put it in context. Those are the relativistic electrons that the GOES 16 and GOES 18 measure from their geosynchronous near equatorial orbits using radiography at the F layer of the ionosphere. So that's where they measure it. From much higher above, they use radiography to determine how many free electrons are there and to measure the vibrational frequency and so on. That's done from the ground. Anyway, the F layer is where the measurements are made from the GOES 16 and GOES 18. So let's take a look at the ionosphere's vibrational frequency. So there's what's going on at the bridge between Earth and space. We do expect to see some significant anomalies here, as the major incoming space weather will have some effect on this. No, it's not going to cause wind currents on the ground. That is not the way space weather works. Don't get space weather and Earth weather confused. They are different things. There's a reason we call it space weather and meteorology, because space weather is not Earth weather. And some folks are making advancements as to how the two do tie together. So here's our anomalygram. We showed you the vibrational frequency. This is the anomaly in megahertz from a 30-day median. It actually shows a little bit higher resolution also. And indeed, some major low-frequency anomalies happening there. So those are probably denser portions of the ionosphere. Perhaps the areas where plasma is making its way down, as less vibration is typically going to be associated with things like lower temperatures, as when the sun shines on the ionosphere, it makes it puff up because it's getting lighter, the same way it makes the air pressure on the ground lighter because it causes convection. Of course, it's a little different series of processes at the ionosphere layer because there's practically no air there and most of the material is ionized, hence the term ionosphere. Anyway, let's show the latest image. This is 1415 universal time ionogram and 1415 universal time anomalygram. And again, you can see all those low frequency anomalies happening. Those are probably the locations where you can expect to see rapid stratospheric warming events. Next, looking at the total electron content, that is the free electrons between your GPS satellite and your handset. That's a run of about 12,500 miles. And free electrons cause signal refraction. So let's see the total electron content. This is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, or CTIPE. And things actually fairly normal here. No major anomalies, although we do still see these consistent anomalies over the northern Caribbean and the southern tip of South America. We see low electron contents right there north of Hispaniola and around Argentina. Not sure why. If you've got theories, drop us a line in the comments. And let's move on to our high-res images before we move to meteorology. So here are our high-res images of the closest star. There is, wow, that is one heck of a sunspot group. That is a bulky sunspot group. And it's very oblong here at the moment because you can see a huge leading umbra there of North Pole orientation and small trailing umbrae. So that means that obviously these fields are going to be much stronger than these fields back here. And that, in my opinion, makes it more likely to flare. In other words, if these sunspots, these trailing South Pole sunspots, were as large as these leading sunspots, this would be more stable. I believe it's less stable because of the disparity in magnetic field orientation. Let's also take a brief look at this group as it sets. It looks like it's been degrading, actually. But it is still beta gamma class. It's still beta gamma delta class. So both of those groups are certainly capable of producing large flares. Here's the rest of the rock back. Interestingly enough, we are getting some very low latitude sunspots here. So this one here is very low latitude, obviously. That one will get a name today, most likely. It is beta gamma class, at least. And this group over here is just alpha class, so let's move on to meteorology. And it's a great segue there. As we move from space to Earth at the Smash News Network, least busted name in news, we're showing you the nullschool.net images. And I'm not exactly sure what cover-up is in full swing. I don't know what you're talking about, Cookie Spacey, but thanks for leaving a comment nonetheless. So here is the nullschool.net imagery of the likely auroral ovals. One of the many features of nullschool.net, if you click space, it'll show you the auroral oval estimation. So things have calmed down a little bit since we actually did show prep. And let's get into meteorology here. We've gone from space weather to Earth weather. So there you go. Those are the jet streams of the eastern world. These are the surface winds of the eastern world. Surface winds of the western world depicted here. And like sands through the hourglass of time, these are the jet streams of your lives. Oh, the toxic train wreck. Yeah, I don't know why it took the feds so long to respond to that, but whatever. Here are the jet streams of the central world. How about a dumpster fire train wreck? That's what bureaucrats have looked like for the past 3 years. What do you think? Here are the surface winds of the central world. Whoa, don't do that. Apparently, if you double click, it will zoom in. All right. And of course, one of the issues with all of this is that a lot of people have a lot of phony saviors. So a lot of people think that they're going to rely on one person to do this or do that, and it's always, always just categorically a failure. What's not a failure is our latest affiliate/sponsor, Hemp Lucid. So check the links for that and save some cash by entering the promo code SMASHOMASH. Yeah. The promo code is now SMASHOMASH, so you can use the link to save some cash, or just go to hemplucid.com and enter the promo code SMASHOMASH on checkout to save some money. If you're unwilling or unable to open your cobweb-encrusted wallets, why not visit the official website of the Smash News Network, least busted name in news, smashomash.com. And welcome to the Neo Renaissance. You can find us all over social media. Thanks to everybody who actually follows us. And once again, we're surprised that you're able to even see this video. If you're viewing on BitChute, make sure you view on YouTube. You're missing most of the content. Thanks to our YouTube subscribers. And here's a little tidbit from last night. We'll show a little clip here from our Aurora Borealis video. So the camera fell over, and if you want to see some aurora over Lehigh Valley, Pennsylvania, we've got it. So here's what's going on in terms of water vapor over the Western world. You know, the Americas. Shout out to our viewers from all around the planet as we zoom in closer and closer to the U.S. That is what's going on croissant Earth. Yeah, Earth. It's croissant-shaped. Yeah, I like to be controversial and state facts. You know, to quote Seinfeld, it's funny because it's real. Croissant Earth, here projected onto a spherical template. All right, headed to weather.gov to show the weather alerts, and we're going to have some snow in Pennsylvania in all likelihood. So very low year for snow. In fact, the last 5 years have been incredibly low for snow in the Boston, D.C. corridor. There are the keys to see your weather alerts, and we've got blizzard warnings continuing for huge portions of California, where like 4 feet of snow are continuing to be predicted. Weather.gov is the location. If your location's lit, click your location. Here are some forecasts. This is pressure and precipitation based on the GFS 72-hour model. So there's pressure and precipitation. Ice storms are coming. In fact, ice storms are already happening. So keep an eye on the pink. Some significant ice storms, especially around the Great Lakes region, and some heavy precipitation continuing to be pumped in from the Pacific into the left coast. California, land of fruits and nuts. Next, our GFS 72-hour accumulated snow depth forecast. Expecting like 2 inches here in Pennsylvania. We are excited. Even though it's going to curtail the bike riding, it won't last long. Look at the snow totals showing up here in California. Yowzers, shout out to Smash Staff's mom. There are 4 feet of additional snow forecast for the eastern portion of California, around the California-Nevada border, Tahoe, etc. Dag, Big Bear has too much snow in order to be able to ride at the moment. The passes are impassable. Even your powder board is not going to rescue you. So let's show the difference between the Euro and the GFS forecast. There's the Euro forecast. Oh, let's switch to new snow. So we've got snow depth. There is new snow for the next 3 days, Euro model, and there's new snow for the next 3 days, GFS model. Once again, Euro model, GFS, back to the Euro, back to the GFS, and back to the Euro. The Euro, a worse currency than the U.S. dollar. Yeah. A worse currency. If you think the U.S. dollar is collapsing, folks, where are you going to hide? Where are you going to invest? The U.S. dollar is superior to the other fiat currencies. The euro is worse. The yen and the yuan are much worse. So don't be ridiculous. The U.S. is not losing its spot as the financial hegemon. Keep in mind, folks, lightning does strike twice. Let me press refresh here, as that is not showing what we'd like to see. It's not a very good animation. We had some severe thunderstorms here over the central part of the U.S. Let's see if we have any terrestrial strikes at the moment. It looks like we may. Lake Michigan is experiencing a thunderstorm. Perhaps thunder snow there happening just east of Milwaukee. Check it out. Thunder rolling in there at Milwaukee. Shout out to Red Letter Media, one of the best YouTube channels ever, Red Letter Media. Shout out to Mike and Rich and Jay, creators of some fantastic content, analyzing movies and being generally hilarious. So here we're going to close out with U.S. Doppler radar, clouds, and water vapor over the U.S. That's what's going on for the full 50 states of ALSA, the allegedly United States of America, former nation, now banana republic. There is the lower 48 U.S. Doppler radar. Here is clouds and fog over the lower 48. Powerful low there rotating just crossing the Missouri-Illinois border at the moment. It'll be even more obvious in water vapor. You see that counterclockwise rotation and a huge pressure gradient happening right here, where dry mass of air is meeting moister air there and providing an impulse to push it up to the northeast. Anyway, here is your recap to close things out. U.S. Doppler radar, clouds and fog, 3.9 nanometer infrared radiation satellite, and there is water vapor. And here is me thanking you once again for tuning in. Don't forget to press like, subscribe, share, etc. Tell your friends and foes about us. We don't believe YouTube recommends the videos. We think the hashtag system is broken, and we think big tech are criminal organizations. So thanks for tuning in once again to the Smash News Network, least busted name in news. This is me, Dan, a.k.a. Smash on Mash, signing off, wishing that solar wind be at your back.